Hello everyone. We talked about the actual forces in the last week and how to calculate the tension, the compression, all those forces for drill collar and drill pipe. During this week, we're going to talk about the pressure loss calculations. When the fluid passes through the pipes, it has a friction with the steel of the pipe. It could be drill collar or drill pipe, different sections of the wellbore. And as it passes through that part of any part of basically the wellbore, it has some frictions, and that friction shows up as pressure loss. This pressure loss of the fluid is important for us because, for example, you want to select a drilling fluid pump to inject the drilling fluid inside the wellbore, right? You need to know how much pressure you need in order to, for example, inject the drilling fluid through the drill pipe, passing through the annulus to the surface, and have some specific pressure at the surface, or at least it reaches to the surface, right? These pressure calculations therefore are important to understand and to see basically where and at what portion of the wellbore we have what pressure. Usually these pressure drops happens due to the friction to the conduit or drill pipe, drill collar. But also it happens inside the drill bit, inside basically the tools that we have through the chokes or any other restrictions that we have inside the wellbore. So in general, the drilling hydraulics is affected by 5 factors. It's basically a function of the flow rate. As you increase the flow rate, the pressure drop of your fluid increases because you will have more friction to the basically drill pipe or drill collar surface. And then you have basically, as the flow areas increases, then you have less pressure drop because your rate will basically drop, right, as you increase the cross-sectional area of your pipe. The length of the system have effect. As the length increases, the pressure drop increases because it basically produces more friction. The longer the length, the more the friction basically. Fluid properties such as viscosity, the higher the viscosity, more resistance to flow, and basically more pressure drop for the fluid happens. And difference in hydrostatic pressure of annulus and drill string would also causes basically to need us requiring more pump pressure. So eventually, as the pressure drop increases, you would need higher pump pressure because you need to take the fluid from the surface, take it all the way back to the surface through the annulus, right? So the higher the pressure drop, you would need to insert more pressure to your fluid in order for your fluid to reach the surface. Drilling hydraulics, which is the topic of this chapter, considers the hydrostatic pressure. Because you have, for example, a vertical wellbore, right, at different depths. If you have a static fluid at different depths, you will have different hydrostatic pressure. So drilling hydraulics consider that. It also consider the dynamic of your system as fluid flow through the pipes and annulus. And if you have a static fluid, there is no friction, right? So it's just the hydrostatic pressure that is the difference between the pressure at different lengths or depths, right? Once the fluid starts to move, then there is a friction and there is a pressure drop that you need to count in your pressure calculations. It also considers the pressure drop through the restrictions, right? So for example, bits, chokes, tools, mudders that we have, and all these components. So we will cover some of it. We will cover the fluid flow through pipes, hydrostatic, we kind of covered it, right? But we will also talk about that hydrostatic further as well in our pressure drop and pump pressure calculations. So now the pressure drop across the drill pipe and drill collar depends on a couple of factors. One is the geometry, of course, right? So if you have basically a drill pipe that is uniform, the pressure should be different from a drill pipe that comes here, maybe become a bit restricted for some specific reasons, and then continue. So the geometry would have effect, right? The rheology of your fluid, is it a Newtonian fluid, non-Newtonian fluid, Bingham plastic, power law fluid, Herschel-Buckley model, all these basically fluids have different pressure losses that we need to consider them, and also the fluid regime. So flow regime, we will talk about it. We have either laminar flow or turbulent. You have learned probably that in your fluid mechanics course, but we will talk about that as well. So in pressure drop calculations in general, there is a pump at the top, right? So you have a pump that you inject. It's basically connected to your mud tank, and it needs to inject this drilling fluid into the drilling system with a specific pressure, which we call it pump pressure. And the pump pressure depends on the pressure drop that happens across your drill pipe, right, which is shown here, right? That's the first parameter. It depends on the pressure drop that happens through your drill collar, right? So considering that, there is a drill bit here, right, and that drill bit needs to be counted as well, right? So and that's the pressure drop across the drill bit. So it's here. We will talk about this. And then the fluid passes through the drill bit, comes to the annulus, to this location. So there is an annulus here, which you need to consider pressure drop across the drill collar annulus, and then enters the drill pipe annulus. So you need to consider that pressure drop, and also eventually consider your hydrostatic pressure difference, right? That happens. So we'll talk about all these parameters, right? And we will consider all these parameters in our calculations. So in the next video, I'm going to start with drill bits, and then we will talk about other parameters as we go.